The topic of the session, the chapter 5, is quadratic equations. The quadratic equations are also one of the most important concepts in mathematics as the linear equations. As we have discussed about linear equation is a linear polynomial equated to 0. Similarly, I can say a quadratic equation is a quadratic polynomial equated to 0. And then let's see how it has come into existence in mathematics. Say for example, I had a rectangular plot whose area is 800 meters square. To start with, quadratic equations. Now, importance of quadratic equations is that we use this in many branches of other topics, even in science, where this is the most important concept. So let's see its origin. So for example, I have a rectangular plot whose area is 800 kilometers square, or I say it is 1600 meters square is the area of this rectangular plot. Then I know the length, but I have to adjust the width. Then let's see how we can do that using quadratic equations. So for example, a rectangular plot with area 1600 meters square is given to be with its length 4 times that of breadth, or I can say in addition to 4, it is added with 4 to that of width, so that when I take my width as x, then my length is x plus 4. If this is the minimum information given in a rectangular plot, then I can find the length and width using a quadratic equation. Then let's see how a quadratic equation is generated from this introductional problem. Now, as we know that the area of rectangle here is given to be 1600 meters square, then I next use the area of the rectangle, which is length times its width. So length being x plus 4 times of width being x would finally give me 1600 meters square, which in turn gives me x squared plus 4x minus 1600 equal to 0. So this is how I get when I take all the variables and all the constants to the left and only keeping 0 on the right hand side. Now such equations which I obtain in mathematics for the given situational problem of a rectangular plot is called a quadratic equation. Quadratic because the highest degree is 2. So a quadratic polynomial, when I equate to 0, is on the whole called a quadratic equation. So we are going to study the different properties in quadratic equation in this session. So let's start with the basic definition of what is a quadratic equation in mathematical definition. A quadratic equation, what is it in mathematical definition? A quadratic equation, if we understand in the general form, it's a quadratic polynomial equated to 0. Of course, a quadratic polynomial in variable x, if I equate that to 0, then that equation is called a quadratic equation. And a quadratic polynomial is already discussed in the previous sessions, where a polynomial of degree 2 is said to be a quadratic polynomial. Now, if I take the quadratic polynomial in general form, then I assume the quadratic polynomial in general form as ax squared plus bx plus c equal to 0. This is called a quadratic equation in general form. And the condition here is that a is not equal to 0 and each of a, b, c are real numbers, and here x is the unknown, which is the variable. So the variable here is identified to be x. Is how I define the quadratic equation in X. This is the basic definition of quadratic equation in general form. Now, as we have seen that a linear equation has only one solution, then the quadratic equation has two solutions. A cubic equation has three solutions, so on and so forth. A polynomial of degree n has n solutions. Therefore, we always identify the two solutions for quadratic equation by using various properties, which we're going to discuss in the next sessions. So how to find the value of x is the next biggest question in this. How to find the unknown x? What are the different methods of finding x is what we're going to see, which is called finding of solution of quadratic equation. To start with an example for this is 2x squared minus 5x plus 6 equal to 0 is an example of a quadratic equation where the value of a is identified to be 2 because I compare this with the standard form of the quadratic equation, which is ax squared plus bx plus c equal to 0. Then b is minus 5 and c is 6 and the variable x is x. So this is clearly an example of a quadratic equation. But if I take 0x squared minus 5x plus 6, this is not a quadratic equation because this fails with this condition, a equal to 0. That implies not a quadratic. This cannot be a quadratic. Is how I understand the quadratic equation with each of its basic definitions. So now that we have studied about quadratic equations, let's see where is quadratic equation applied in real life. Where do we use in the daily life is very important because we use this in various branches of science, especially physics. So applications of quadratics. Quadratic equations in daily life. Initially, if, for example, I take a person standing here on the ground, then he throws a ball onto this side, then the ball tries to go in this shape, then this is said to be a quadratic equation. Throwing of a ball or path of a projectile, this is called a projectile, which gives us a quadratic equation. So the first application is path of a projectile is a quadratic. Similarly, let's see, for example, I have, say, a rocket. Usually rockets go into the space from ground. Say I have a rocket which is out here, and once it is launched, then this tries to go straight into the sky, but we generally assume that it goes straight in the sky, but no, it doesn't go straight, but it goes in like this into the sky, and then it goes outside of sky everywhere, crossing the sky into the space, into the moon sometimes. Therefore, the launching of rocket, the moving of a rocket from the ground is also a quadratic, can also be represented using a quadratic, is one of the way of understanding the quadratics in real life. Also, there are many other applications. Say, for example, I take a vehicle. I have a vehicle, then when it is going very fast on the ground, then if I put the sudden brake, then the stopping distance is also a quadratic. The stopping distance of a vehicle is also a quadratic. Is representing a quadratic is how we understand the various applications of quadratics in real life.